Hi guys, welcome to NEET world of NSEJS class. So in this session we are going to see the previous year questions of NSEJS for class 8th, 9th and 10th. So in previous classes we have solved many PYQ question in the NSEJS, and in this class we will go for the next part of the PYQs of NSEJS. So the first question of this class is: three identical electrical bulb A, B, C having a specification 60 watt, like the 220 volt are connected across a 220 volt supply as shown in the given figure, right? The total power dissipated in 3 bulb is close to. Okay, so they are asking what is the power dissipated in the bulb, right? The total power dissipated in the 3 bulb. Okay, so the solutions, how to find answer for this question. If you take each bulb resistance is R is equals to V square by, it's V square by, I should change this, right? Where is eraser? Yes, it's V square by P, okay. It's V square by P, okay. For the circuit, bulb A is in series, with the parallel pair, okay, with the parallel pair, that is B and C. You can see here B and C. So R equivalent will be equals to R plus R by 2. So for the first one, A, for A bulb, no, it is R. For parallel case, it is R by 2. So total value will be, so if I take the LCM, what will happen? Cross multiply it. So 2R plus R by 2, no, that's it, na. So total value will be 3R by 2. Fine. So this is my resistance. I will keep the resistance. Okay. Now I need to find the current goes in the circuit. So for that, the total current will be, we know that V is equals to, I will write V is equals to IR. No. So from this, I is equals to V by R. Okay. V by R. Okay. So what is R? R equivalent 3R by 2. No. Yes. So V by 3R by 2, which is nothing but 2V by 3R, okay, 2V by 3R. So when I take this 2 to the numerator, it will become 2V by 3R. Now the total power, I need to find the power dissipated. No, power is nothing but I square into R equivalent. I know that the total current now, and R equivalent is nothing but R equivalent is equals to 3R by 2. Fine, 3R by 2. Now take the value of IE and R in this equation. What is I? 2V by R, that is 3R the whole square into 3R by 2. So when I do this calculation, and note that V square by R is nothing but 60 watt. Okay, I will keep this as it is. Now do the calculation here. So this one will be 4V square by 9R square is into 3R by 2, where this R and R will get cancelled out. 1 times and this 3 times, no, 3 times, and this 1 time and this is 2 times. Fine. Okay. Now what will come? 2V square by 3R. So what is the value of V square by R? It is 60. I will write that one. So is equals to 2 by 3 into 60, which is nothing but this 1 times and this is 20 times. Answer is 40 watt. This is the answer. Okay. This is the answer for the first question. Nothing is like I need to find the power, that's it. So for that, I need to find the resistance, like total resistance and then current. Okay. So we'll go for the next question. Okay. A copper wire is stretched to decrease its radius by 0.15 percentage. The percentage change in the resistance. Okay. So radius has been decreased. So assume that volume is constant. Okay, volume it's constant. No, like copper wire is stretched. So copper wire is stretched in the sense like some volume is there. If I stretch that, is volume changed? No. Like the length, like the radius has been changed there. The radius has been changed. So assume that usual stretching, that AL, area and length is constant. Whereas A is nothing but R square, no. Like A is directly proportional to the radius square. Pi R square. Circle radius, no? Yes. So pi R square. So from this, change in area by original area will be equals to 2 times change in radius by radius. So radius has been decreased there. So decreased in the sense 2 into minus 0.15 percentage. Fine. Decreased. That's why I have taken minus. So what will be the answer? Minus 0.30 percentage. Okay. Now I need to find the resistance. What is resistance? Resistance is nothing but R is equals to rho L by A, no? Rho L by A. So change in resistance, like percentage, no? Percentage they are asking. So percentage in the sense, I will write in here. So R is equals to rho L by A, where rho I will keep as it is, resistivity. So delta R by R should be equals to, if I take R, I can write here, R is directly proportional to L A power minus 1. Now you can apply that. R, delta R by R is equals to delta L by L. The power is there, minus 1 into, yes, minus 1 into delta A by A. Okay, delta A by A. Fine. If you see here, del A and L is equals to constant, right? A and L are constant. So L will be 0.3 percentage. So what about area? Area will be minus 0.3 percentage. So I can write here. So 0.30 minus of minus 0.30, which is nothing but 0.60 percentage. This is the resistance. So what is the given option here? Option A 0.3, option B minus 0.3, option C 0.6. Yeah, option C is the answer, 0.6 percentage. Right now? Yes, we'll go for the next question. Yes, can we go for the next question? Okay. Okay. A small bar magnet is allowed to fall vertically through a metal ring lying in the horizontal plane during its fall. The acceleration of the magnet in the region close to the ring must be. G is the acceleration due to gravity. Okay. So options are equal to G, less than G and uniform. Option C is less than G and non-uniform. Option D is greater than G and uniform. So let me see what are the things available here for the solution. When the magnet falls through the ring, the changing magnetic flux induced a current in a ring, that is Faraday's law. Okay. The induced current produced a magnetic field that opposes the motion of a magnet, that is Lenz's law. So hence the magnet's acceleration becomes less. Yes, a magnet acceleration becomes less than G, and since the opposing forces depends upon the velocity, right? Yes, opposing forces depends upon the velocity, it's non-uniform. So which of the given option correct here? Less than G should be there and it's non-uniform. So less than G, option B is there but it's uniform. Less than G, option C is there and it's non-uniform. So option C is the correct answer. So by using the Faraday's law and Lenz's law, we can solve this question, right? Okay guys. So in next class we will see some more question of PYQs. So stay tuned for the upcoming classes of NSEJS. Thank you.